Good morning, friends. Today, myself Priyanka from BSc Chemistry Honors Final Year. I'm here to introduce you to about organometallic compounds and their type of organometallic compounds and their preparation. And at last, we will discuss about preparation of Grignard reagents with different types. So let's start the discussion. First of all, what are organometallic compounds? The compounds in which there is metal carbon bond with some exceptions are called organometallic compounds. That is, the organometallic compounds are those compounds in which there is one metal and one carbon, and the bond between them is organometallic bond, and the compound is named as organometallic compounds. But there are some exceptions also. For example, Grignard reagent, alkyl lithium, dialkyl zinc, dialkyl cadmium, tetraethyl lead. There are many examples of organometallic compounds. In cyanides, carbides, there is metal carbon bond, but their properties do not matches with the properties of organometallic compounds, so they are not considered as organometallic compounds. Then we will discuss about the types of organometallic compounds. There are first type of organometallic compound is simple organometallic compound. So what are simple organometallic compound? That means that are those compounds in which metal is linked only to the alkyl group. That is, for example, alkyl lithium, alkyl zinc, dialkyl cadmium, etc. Because they have metal carbon bond with covalent character. Second type of organometallic compound is mixed or complex organometallic compounds. The compound in which metal is linked to the alkyl group along with the X group. मतलब मिक्स्ड कॉम्प्लेक्स ऑर्गेनिक मेटेलिक कंपाउंड वो कंपाउंड होते हैं जिनमें जो मेटल है वो एल्काइल ग्रुप के साथ भी अटैच है एंड along with the halogen group. For example, Grignard reagent. They have metal carbon bond with ionic character. So there are mainly two types of organometallic compounds, and that are simple and mixed or complex organometallic compounds. Then we will discuss about reactivity of organometallic compounds. The reactivity of organometallic compounds depends upon the ionic character in metal carbon bond. As more the electropositive nature of the metal, more the polarity of metal carbon bond. That means more will be the ionic character in the given organometallic compound, and more will be their reactivity. Means we can relate that polarity of metal carbon bond is directly proportional to the ionic character of the organometallic compound, and that is directly proportional to their reactivity. The metallic character of some elements is, there is given the order for metallic character. Potassium is more reactive than sodium, than lithium, then come to magnesium, then aluminium and zinc, cadmium and mercury. So order of polarity is also for potassium carbon bond is more reactive than sodium carbon, then lithium carbon bond, and so on. Hence the reactivity order will also be the same because they are directly proportional to each other. Alkyl potassium is more reactive than alkyl sodium, than alkyl lithium, and so on. The organometallic are of great importance because they involve the information of carbon-carbon bonds. Here we can see the bonds. Ketone is reacting with Grignard reagent, and then we get the alcohol with more number of carbon atoms. Also, Grignard reagents. What are Grignard reagents mainly? The organomagnesium halides are called Grignard reagents. and it is denoted by RMgX, where R is the alkyl group, Mg is magnesium, and X is the halogen group. R, and it is discovered by Victor Grignard and awarded by Nobel Prize in 1912. Then we will discuss about preparation of organometallic compounds. Preparation of organometallic compounds from alkyl halide. So, on reacting alkyl halide with Mg and dry ether, we get Grignard reagent. Also, it shows Unpolen effect. Unpolen effect means the reversal in the polarity of carbon attached to the halogen group during formation of Grignard reagent from alkyl halide is called Unpolen effect. Then preparation of alkyl halide to alkyl lithium takes place in the presence of lithium and dihexane with nitrogen gas. In this reaction, lithium shouldn't be pure. It must contain 0.02% Na. Then alkyl halide conversion into alkyl zinc takes place in the presence of zinc and dry ether. Then uh, for a given alkyl group, the reactivity order of an halogen is chloromethane is less reactive than bromomethane because with the increase in the number of carbon atom in alkyl group, the formation of Grignard reagent becomes difficult. And for the preparation of vinyl or aryl magnesium halide, a stronger base like tetrahydrofuran is required. Due to the involvement of lone pair of electrons in resonance, there becomes the strong double bond between the carbon and halogen group. It doesn't mean that the reaction of vinyl or aryl halide with magnesium cannot take place with dry ether because the reaction will occur but the yield is very poor. Mechanism for the preparation of alkyl magnesium halide. Here we can see the two electrons of magnesium. One electron goes to bromoalkyl and another one goes to another alkyl bromine compound, and it converts into double alkyl group and MgBr2. Then it further reacts with Mg and forms the compound R plus MgBr2, where R has one free radical, and it will also react with MgBr and convert into the Grignard reagent. For this conversion, solvent should be aprotic because Grignard reagent can react with protic compounds having active hydrogen like OH group and carboxylic acid group. Second, preparation for organometallic compounds with metal exchange reaction. Alkyl lithium, when reacts with MgBr2, gives us Grignard reagent. And now we will discuss about reaction conditions of organometallic compounds. The following precautions should be taken during the synthesis of Grignard reagent. First one is activation of magnesium metal. Magnesium metal is usually unreactive due to formation of oxide layer on its surface. Hence, it should be activated by dislodging this layer. It is achieved by adding small amount of iodine or 1,2-diiodoethane or by using ultrasonic sound. This problem can also be obviated by using weak magnesium, which is in the form of highly reactive small particles of magnesium with large surface area. And also weak magnesium is prepared by reducing MgCl2 with lithium metal. We can see the reaction. When MgCl2 react with lithium metal, we get the weak magnesium. Second precaution is solvent. Ether solvent like diethyl ether, tetrahydrofuran, dimethoxyethane or dioxane are not suitable for the preparation of Grignard reagents. It is because they are not only passive with magnesium but also dissolved and stabilize the Grignard reagents by forming Lewis acid-base complexes. Here we can see the reaction for forming the Lewis acid-base complexes from the Grignard reagent. The dry ether cannot be used as solvent during the synthesis of alkyl lithium because dry ether can react with lithium metal. Third precautions we should have taken for organometallic compounds reactions is anhydrous conditions avoiding moisture. The major disadvantage of Grignard reagents is they react with protic compounds like water, alcohols, thiols, etc. Hence, the reaction must be carried out under anhydrous condition avoiding moisture. Fourth precaution is nitrogen or argon atmosphere, that is inert atmosphere. These reagents must not be exposed to air as they also react with oxygen by giving peroxides species which are converted to corresponding alcohols during hydrolytic workup. We can see the reaction, that is Grignard reagent gets react with oxygen to form peroxides, and then finally they convert into the alcohols and some minor compounds. To avoid this, it may be preferable to carry out the reaction in nitrogen or argon atmosphere. Then after this we will discuss about preparation of different types of Grignard reagents. First type is the alkyl Grignard reagents are prepared from the corresponding chlorides or bromides or iodides, and their order of reactivity is alkyl chlorine is less reactive than alkyl bromine, is less reactive than alkyl iodine. Alkyl fluoride are seldom used due to much less reactivity. Second type is the alkynyl and phenyl Grignard reagents are prepared from the corresponding bromides or iodides in more effective coordinating solvent like tetrahydrofuran, because tetrahydrofuran increases the reactivity of alkyl or aryl halides towards magnesium. So, Grignard reagent of less reactive aryl or vinyl halides is prepared in tetrahydrofuran. We can see the reactions for vinyl bromide when it reacts with magnesium and anhydrous tetrahydrofuran, it converts it into vinyl magnesium halide. And bromobenzene when reacts with magnesium in the presence of anhydrous tetrahydrofuran got converted into magnesium halide with benzyl group. And the third type for the preparation of Grignard reagent is the alkynyl Grignard reagents are prepared by deprotonating one alkynes with another Grignard reagent like ethyl magnesium bromide. Propyne can be deprotonated with ethyl magnesium bromide to give propenyl magnesium bromide. Here we can see the reaction. When converted, ethine is get reacted with the presence of ethyl magnesium bromide and anhydrous tetrahydrofuran, it gets converted. The one hydrogen is get removed, and in place of that hydrogen, MgBr group is attached. Fourth type is the allylic Grignard reagents may undergo coupling reactions. Hence, they are generated whenever required in the Grignard reactions. Fifth type is Grignard reagents can also be prepared by transmetallation. Alkyl lithium can give Grignard reagents when treated with magnesium salts. When alkyl lithium reacts with MgBr2 in the presence of tetrahydrofuran, it gets converted into the Grignard reagent, that is alkyl magnesium bromide. Here our chapter organometallic compounds ends. I hope you will understand the chapter with my explanation. Thank you.